Okay, so you say a binary random variable x can take only two possible values. So actually, for Bernoulli distribution, correct? They don't have a value. Do you realize that? They say two possible value, one to represent success. Look at your textbook. I'm reading from your textbook. One to represent success. Actually, they don't have a value. They have two situations. One called success, the other one called failure. So when you talk about Bernoulli distribution, you have to talk about success. So you don't just say success. Okay, like for example, let's look at example 10. Okay, when you look at the example 10, what is the success? So you have to talk about the situation. Are you clear? You have to talk about the situation. Okay, what is the success in example 10? Can you tell me? What is the success? Success is getting what? A red pen. So this is called success. Correct? You cannot say, because there are two possible value. Okay, one is the success, the other one is the failure. You cannot just say like that. You have to say that the success is getting a red pen. Okay, then what is the failure then? So getting a red pen. So we use this because you want to be a statistical variable. It must be measurable, correct? It must be something that is got value. So what do you represent? So you use 1 to represent this. To represent getting a red pen. Okay? When you draw a pen from the box. Am I right? So you have to specify your success. Okay, then what is the failure here? What is the failure here? Is, okay, if we said getting a blue pen, or we also can say not getting a red pen. Why I want to put it like that is because sometimes in the box, you can have more than one color. Correct? This one just happen to have 2 colors only. Am I right? So there are only 2 outcomes, either getting a red pen or not getting a red pen. So you use 0 to represent this. So this is how I explain it is a Bernoulli random variable. Do you get me? You have to specify. So this is a Bernoulli random variable. So I've explained that. And the next one, you have to explain that the probability of or sum of the probability must be equal to 1. So you build the probability distribution table. Okay, so what is the probability of getting a 1? Getting a 1 here. I mean, getting a red pen. Huh? Okay, why you say half? So how do you get, where do you draw the red pen from? from a box that contains 7 red pen and 3 blue pen. You draw 1 from here. Am I right? So if I have 7 red pen and 3 blue pen in the box, so what is the chances of me getting a red pen? It will be 7 out of 10. Not a red pen will be 3 out of 10. So the sum of the probability is equal to 1. So this fulfills Bernoulli distribution. Bernoulli distribution, it must have 2 outcomes. And the outcomes is not numerical. The outcome is either getting something, you use 1 to represent it, or not getting the same thing, using 0 to represent it. Do you get me? So if I just put like that, without letting all this logic number 1 and 0. So 1 is for true, 0 is for false, correct? You learned this before in your high school. The truth table, got not? Okay. Nowadays syllabus, they cut off this part. SPM got. Hello, SPM ada kan? Max ada kan? The truth table, ada belajar physics ah? Get logic ada belajar? Aha. Aha. So do you know now why you learn binary system? You still remember what is binary system? 1 plus 1 equal to 1, 0. Hello? Ada tak? Aduh. Why you need to learn base 2 system? Do you know in maths you got base 2 new number system, base 8 number system, base 10 number system? All the number we are talking about every day here is base 10. Do you know the meaning of base 10? That means you start with 10 to the power 0, 10 to the power 1, 10 to the power 2. Number system. So this one, that's why you call it 100. If I put here 2, I got 200. I put here 0, I don't have a 10. And I put here 5, this is 1. So I read as 205. But if I put base 2, it will be 2 to the power 0, 2 to the power 1, 2 to the power 2, and so on. So if I put here, so if base 2, I can only use 2 digits. What are the digits? 1 and 0. Why you learn 1 and 0? Because you learn binary system, because your gate logic is either on or off. Like for example, our case here is yes or no. So you use 1 to represent yes, 0 to represent no. So all your gate logic is either on or off. 1 is on, 0 is off. If both are on, 1 and 1, you will get what? 1. Hello. You didn't learn gate logic, the truth table. Okay, tak apa, balik ke sini. So that's why you need maths before you do your science or do any logical thinking. Okay, so get it? Okay, so that is how you explain. X can only take 2 possible values. The book explained like that is not that good, 1 and 0. You say success is getting a red pen, 1 to represent getting a red pen. And failure is not getting a red pen, so 0 to represent. So you can take only 2 values, that is 1 and 0. I define when is it 1, when is it 0. Are you okay? So then you say the sum of the probability. Then count the mean and the standard deviation is very easy, correct? Hello? Boleh? Okay, good. Done, huh? So the main thing of this. So now, if I put a general form of this probability distribution table, one, we have to define what is one and what is zero. Okay, so what is the probability of getting a one? I put P, small letter P. So what is the probability of getting a zero? 1 minus P. That's why they say the mean is equal to P. And the standard deviation is equal to square root of, so you use the formula. So the book have given you. So I expect you to look through it by yourself. So it's sum of xi squared times P minus mean squared. Am I right? So you will get P minus P squared. Okay, so this is the general form. So listen here, Bernoulli distribution. How many draw? One draw. Success, you have to define. Then you use logic 1 to represent success. Failure, you have to define. And you use logic 0. So that's why we say there's only 2 outcomes. Yeah. Can or not? Okay. So the textbook, the way they explain, it may mislead you. It's not only 2 outcomes. And the 2 outcomes must be of not numerical value. Are you clear? Okay. So now let's look at exercise 7F. I will go through question 1 with you. Yeah. So before we go to G, okay. So today we are going to do 7F. Okay. Now let's do number 1. Okay. A coin is tossed. X equal to 1 if the result is head and X equal to 0 if the result is tail. So is this a Bernoulli distribution? Yes or no? Yes. Okay. Explain why. So what is your success? Getting ahead. Right? So you use X equal to 1 to represent it. Yeah? Okay. Failure is what? Not getting ahead or getting a tail. That means not getting ahead. So we use X equal to 0 to represent it. So there are how many outcomes? Only 2 outcomes. And the probability, sum of the probability is equal to what? So you build the probability distribution table. So that is how you explain it is a Bernoulli. You get me? Okay, how about B? 2 coins are tossed. X is equal to the number of head tossed. So can you tell me what is the possible number of X? 0, 1, 2. So I will say X is the number of head tossed. So x is equal to 0, 1, 2. So is this a Bernoulli? So straight away, I will say that there's no such thing as success and failure. Am I right? So therefore, it is not a Bernoulli distribution. Clear? Okay, now, how about C? X is equal to the result when the spinner alongside is spun once. So what are the possible value for X? 1 and 2. Is there a success or failure? No. So therefore, it is not a Bernoulli distribution. Are you clear? So it doesn't mean that only 2 outcomes. So be very, very careful because the 2 outcome is not represented by the logic 1 and 0. You get me? Okay, now how about D? So this is not, Okay, how about D? Yes or no? Yes. What is success? Yes, purchase something. So the success is the person purchase something. Right? So you use X equal to 1 to represent it. Am I right? Okay, then otherwise failure is otherwise. And you use X equal to 0 to represent it. So here they didn't give us the probability we can't do anything. Am I right? Okay, how about E? How about E? Yes or no? Huh? No. When I look at it, I also say no just now from the other class. But you look, he said a letter of alphabet is chosen at random. So that means I have a box. I got 26 alphabet. Right? There are 26 alphabet in the box. Correct or not? We have 26 alphabet only, correct? Got 27 or not? You ask your English teacher at the beginning when they form the English word, correct? Actually, they were only 23, if I'm not mistaken, from the history lah. Then after that, I don't know what they add on to it. Okay. Okay, 26 alphabet. So from here, you draw 1 alphabet. You draw 1. One letter. Correct? So the 1 letter you draw, either it can be is a vowel or not a vowel. There are 2 possible outcomes, correct? So the number of vowel that you get is, for here is, you use X equal to 1 to represent it, correct? If you not a vowel, so you use X equal to 0 to get it, correct? So this is your success. And this is your failure. So is this a Bernoulli? It's a Bernoulli. Okay, can you tell me what is the probability of getting 1? Yeah, 5 out of 26. And this one will be 21 out of 26. So it's a Bernoulli distribution. Okay? So do you get me? Okay? Okay, so let's go to number 2. Okay, now you explain number 2 for me. Explain why X is a Bernoulli variable. Okay, you try not to say there are only 2 possible outcomes, that is 1 and 0. Huh? So how are you going to explain? Can someone? Okay, so we will try to go back to success and failure. Okay, success of a draw is getting a outcome, getting a rate. Okay, then you use X equal to 1 to represent it. And the other outcome is, okay, failure is, the outcome is getting a Y, is Y. The draw is a Y. So you build the probability distribution table, then you find the mean and the standard deviation by using your graphic calculator. Can or not? Okay, so I let you try all the questions in question 1 to 6. Yep. Can you please try it? Define it properly. Huh? Like for example, number 2, I will not say, because like the book, X can only take 2 possible value, 1 and 0. I'm not going to do that. I'm going to say the success, then going to say the X, the failure, then I'm going to say the X. Are you clear? So that will be more, give you a better understanding of the whole thing. Okay? So I will, that means if you say 1 and itself. So if you define like that, then 1 should be a prime number, what? Correct? But why 1 is not a prime number? Okay. Prime number, huh? Okay, prime numbers are numbers with 2 and only 2 factors. It must have 2 and only 2. It cannot have more than that. And it cannot have less than that also. So 1 is 1 times 1. So you have only 1 factor. So therefore, 1 is not a prime number. You see or not? So 2 is 1 times 2. So factor of 2 are 1 and 2. So 2 is a prime number. Okay? Got it? So it must have 2 and only 2 factors. It cannot be more, it cannot be less. Okay. Composite number. Are numbers with more than 2 factors. So I will say like that, all prime numbers are not composite numbers. Agree? Because it might have more than 2 factors. So I will make a conclusion, all prime numbers are not composite number. Okay? Is 1 a composite number? No. Can I not? So that is the meaning of composite number. So when you talk about getting a composite number, correct? Or not getting a composite number from 1 to 20, correct? So when you say composite number, for this case, it will be 3 is not, 4 yes, 5 is not, 6 yes, 7 is not, 8 yes, 9 yes, 10 yes, 11 no, 12 yes, 13 no, 14 yes, 15, all even numbers are except 2. Okay. 15 yes, 16 yes, 17 no, 18 yes, 19 no, 20 yes. So all these are the composite number. Can I not? Okay. So you have to know what is composite number. So you can do that particular part. So that is list out so that you can find the probability. Yeah.